All right, let's go ahead and get started. I'm Greg Conti. Thanks for coming. I hope to do several things during the talk today. The first is to get you thinking and motivated to think beyond today's current tool set and look at new approaches. I'm a big fan of blinky lights, so we have a lot of blinky lights during this talk and almost no bullet slides. So I think you'll find it interesting as well as useful. I plan to show you some techniques I hope that you can use in your own projects. And finally, I'm releasing a tool that I've designed to complement the strengths of Ethereal. Ethereal is world-class in dissecting protocols, but ultimately you're constrained to just a tiny window, primarily of text, to see what's going on. So this tool is designed to see big picture and allow you to interact with the data in a fundamentally different way. So I'm currently at Georgia Tech, but I'm also in the Army, and I'm here as a free citizen and not as a representative of the government. And that would be Fort Leavenworth. I had a tour of there once. Not a happy place. So let's look at how Hollywood has looked at the network problem, the security-related data streams problem. So this is from the movie Hackers, and this is how it was portrayed. In Tron, this is how they observed the network. And of course, the Matrix, and how they monitored the activities going on in the Matrix. And actually, we'll look at the real Matrix today. I think you'll find it entertaining. So first, let me start with one example to help motivate you. And this is from some work I did with Sven Krasser, who was at Georgia Tech, and now he's at Cypher Trust. And each of these are like Rorschach ink blots. So they take a little bit of time to get used to, but once you are, after I've explained it, hopefully you'll see what's going on, and it'll make a lot more sense. So along this axis, I'm going to plot an IP address, the source IP address, and it goes from 0.0.0, et cetera, at the bottom, all the way up to 255.255, et cetera, at the top. So it'll plot a point along that line. And it'll plot the destination port along 0 to 65.535 along the right vertical axis. And then it'll connect the dots. And as it's connected, a glyph will be formed that will move off the screen, and you'll be able to see the activity. And this code is on your CD. It was implemented in C++ and using OpenGL. So this is the tool, the RUMINT tool, and I've named it RUMINT because you've heard of SIGINT for signals intelligence and IMINT for imagery intelligence. RUMINT is intelligence community slang for rumor intelligence. So I thought rumors in the network or ghost in the shell would be the appropriate name. So this is the toolbar / menu with thumbnail views that the idea is you can leave it on your desktop and monitor activities in real time. So I'll go ahead and load a data set. And you can see this is a NSA Red Team data set. And then I'll bring up the view, as well as I've primarily used the PVR interface. So it has 919 packets. And you can play the data. And you can see as the connections are made, it's plotting IP address to destination port. And it's hard. I'm not sure if you can make it out in the back, but the pixels are. You can probably see that the lines are forming. Let me go ahead and change the speed. So the idea being that, say you're running a HoneyNet, you can come in the next morning, play the entire data set, and see what happened. And use that information to find interesting spots for detailed analysis with a tool like Ethereal. And what I've done is it's not just constrained to source IP to destination port. I've currently implemented 17 fields from various common header structures from network packets. And you can connect any two to any two. For example, if you want to run this again, using IP address to time to live, for example, You can go ahead and run the data set again. And you can see the different activity taking place. And if we're already at 800 packets right now, so ideally you can pause it. You can then go and look at that section of the PCAP file in more detail. Okay, so you may have heard about network PVRs or network visualization, and I just was interested in where you think we are on the hype cycle. And with a show of hands, who thinks we're at the technology trigger stage of the hype cycle? This is the deer in the headlights room. How about the peak of inflated expectations? The trough of disillusionment? Okay, good. Probably about, 40% of the room? Hard to tell who hasn't voted. The slope of enlightenment? Okay, no one. Oh, one. Okay, so just a handful on the slope of enlightenment and the plateau of productivity. Okay, so I think the general consensus is the trough of disillusionment, and I'm with you. But I've also noted, I've included a little bit of the slope of enlightenment. I think we're at the point now where we can intelligently apply these techniques in certain ways, and they'll be very, very useful. And hopefully I'll convince you of that during the course of this talk. So I want to show you both how I designed the system as well as a little bit of the vision and direction where it's going. And let me point out, it is under Con CD, so if you want to play around with it afterwards, you're welcome to. So the first part is it incorporates archived PCAP files, or will capture packets live. But it's also important to know, and this is the direction I'm heading in, that it's not just network packets, that there are a wide variety of other security-related data flows that you can bring into this tool and view them at the same time. It makes a lot of sense to do so. So after you've brought in the packet capture data or the other streams, they're sent through a processing pipeline and then are visualized. And each window, and I've got 7 windows in this tool with various interactions and levels. But the idea is I worked very hard to create windows that are useful, that allow you to look into the traffic, into the data in a useful way. And I'm hoping to get your feedback during the rest of Black Hat about where I've succeeded and other places you think there's potential. And it's also useful to think that one of those windows could be an ethereal-like interface. I mean, that could very well be one of the windows. They all run in lockstep, so as you float through the data, they will all change in association with each other, so you can see cause and effect, perhaps, or relationships between the views. And then, after it's visualized, you interact with the data, and I have some better pictures in a moment. So this is the data stream I've focused on right now is PCAP, but it could just as easily be net flows or something, snort, syslog, firewall logs, and that's where I'm working right now is to bring that in, because there's not a whole lot, certainly on the forensic side, there's not a whole lot of technical hurdles to doing so, and I think it makes a lot of sense. And every time I've created a different view on the data, I've always been surprised, and there's insights that come out of it that you didn't know were there. And beyond the traditional things that you think of for security-related data, I also think it's useful to look at some of the less traditional ones, both passive and active collection. For example, P0F or POP does passive operating system fingerprinting. That might be interesting information to bring into the tool and color code by operating system, for example, or filter by operating system, as well as semantic information such as illegal IP addresses, either globally for the internet or for your organization, as well as it being possibly a front end for tools like Nmap. It would be very interesting to pull in the results of Nmap, or Dan Kaminsky did some interesting work, presented some interesting work here about going out, probing the internet and visualizing it. So actually grabbing the information and pulling it back. And the power lies in combining it all in an intelligent way. So far I've got 17 fields that I've got dissecting out of the PCAP file, but it could clearly be more, and that's the direction I'm going in. So I already showed you the main window. The idea is that you could, if you're in just monitoring a network, you could have this running on the desktop. So I talked a little bit about interacting, and it's useful to be able to just view the data as it plays by, but it's even more powerful if you can combine it with filtering and encoding. And by encoding, I mean typically color coding, or changing the sizes or the shapes of the objects that are on the screen. So here are two interfaces I've played around with. I believe filtering and encoding are particularly intertwined. So for example, you can filter TCP just by clicking the button. And if you want to change the color of TCP, you click on the color square. It allows you to change the colors. And clearly, these are very rudimentary, but I want to move to more detailed techniques that give a higher degree of resolution. And ultimately, I'd like this tool to help generate filtering commands that you can just drop into Ethereal. So you find an area, you've interacted with the interface, and then you can use that as a starting point in the more detailed Ethereal language. I've also chosen the PVR or the VCR metaphor because I think it fits very naturally with the data and going forward and backward to it. But if I'm wrong, you feel free to grab me and tell me I'm wrong. And I'm also heading in the direction of a mixing board because I love the idea. If you think broadly, the data is very well structured. We're looking at log data or packet capture data, and it's very well defined what the fields are, what the data types are for those fields. So if you had a mixing board that had every possible field that you were able to operate on and filter on or color code on, and you could slide and constrain the ranges, and all the screens updated. I've done that a little bit on prototypes, but I haven't got it smooth enough and fast enough to actually drop it into the tool yet. But I definitely think it's the right direction to go. And that you as an analyst can bring up the data set, play through it once, find interesting areas, remove uninteresting areas, and work through slices. You find something, you know what it is, you can pull it out, perhaps generate a filter for it for future use, and after that slice is removed, you work on what's remaining. So that's the idea. You work through slices to get down to what's interesting. And perhaps you can share those filters with others. I really like the mixing board metaphor, perhaps even a USB mixing board. That could be kind of neat. I don't know. Maybe you can tell me. Like I mentioned before, I'm not a big fan of bullet slides, so I included a good number in the book because I wanted to give you something down the road when you didn't have the commentary to be useful. So you won't find many in here, and the slides will vary to some degree from the book, but I think you have the book would be a better reference in the future. Okay, I talked about visualizing the matrix. So imagine bits on the wire, bits on the internet, or as seen from your network interface. And if you color-coded them, if every one you decided to make a green pixel on the screen, and you plotted them, one pixel or one packet per horizontal row, so packet after packet, it would look like this. So what you can see here, orange are UDP packets, green are TCP, one packet per line, and each on bit is an on pixel. And what you can see here at a glance, and that's what I'm going for, is to allow you to see things at a glance, hopefully speed up initial analysis. As you can tell the length of the packets very readily. You can see 800 packets at the same time, only limited by the vertical resolution of your screen. If you see vertical lines in the packets, that's the same value between packets, so you can see patterns if things are identical. And it doesn't really show through on this, but you can get a very good feel for consistently changing. If something changes per packet, one bit to the right, you can tell incrementing values, as well as random data becomes very, very apparent. So if you're looking at something, if you're filtering on only a certain port, you could say that's not supposed to be random data coming across that port, for example. So here's a variant where I've color-coded the headers now. Purple are the Ethernet headers, orange are the IP headers, and green is the IP payload. I didn't get down to actually color-coding the lower level. But you can see a very clean delineation then between, after you've got the Ethernet header, the IP header, and then I believe these are all TCP headers, and then you can see the payloads here. And I'll demo this for you in a moment. I think there's also potential, and this is just photoshopped, for navigating within binary objects. So if you look at Ethereal, you've got a window, you can see 30 packets at one time. Perhaps you could navigate among 500 of them and see outliers, things of interest, particularly if it updated when you put in a query or if you applied a filter, the screen would update. So then you can see what ones are the same and what ones are different. Then you could click on the region, it would show you it would give you the details below, which is what Ethereal is excellent at. So let's continue this idea a little bit more, where we were just doing 1 bit per pixel, but the problem is you can only plot 1,200 pixels on 1,200 bits on the screen, which isn't enough to handle the 1,500 or so bytes in some packets. So if we look at it a different way, you take the first byte of each packet and map it to each pixel. So each byte in the packet is mapped to a pixel. That gives you 2 to the 8 possible combinations, or a very nice 256 level, like grayscale, or in this case, a green scale pixel. So you could continue that even more and take every 3 bytes and form a red, green, blue tuple. So you would have the first byte would be red, the second byte would be green, third byte would be blue, and that would be your first pixel to those values. So you could see the network traffic in color. And that compresses it quite well. I've also combined this with the idea of textual displays, because that graphical display has certain uses, but it isn't a cure for cancer. It's helpful for us as humans to be able to see the text. So I also have created a screen where you can look at both the graphical display and the textual display in lockstep with each other. And as part of that, it implemented the strings command. You've probably used it for like looking at binaries. Well, this will do it on the packets as well. So this picture shows strings of length 5. So packets that have printable ASCII strings of length 5. I'm intrigued by the idea of on-the-fly disassembly, that if you look at these as binary objects, perhaps as executable objects, and perhaps do some, and I've only looked at this a little bit, but I'm intrigued that some form of disassembly, which you might be able to do a little bit and color code the display, you might see things that look buffer overflowish. You can tell me if I'm wrong afterwards, but I feel like there's something there, particularly if you reconstruct the flows, that you might be able to see executable code to some degree, or things that would perhaps be missed by you as a human will see things that the signature matching system might not detect. So in this example, and I know this is an older technique, but hex 90 being part of the no-op sled, and when you click the button, it shades everything to gray and highlights the hex 90 bytes or bits in red. And let me go ahead and give you a demo of that. So I'm loading a different data set, which is a HoneyNet Scan of the Month. HoneyNet project had a Scan of the Month competition, and this is from number 21. And you can see at a glance then the lengths of the packets, the basic structure. Many of them are very similar. We can change it to, I just turned on the printable ASCII, so it grays out everything that's not printable ASCII and highlights everything that is. And this is 1 bit per pixel. And we can go to a grayscale mode. Whoop. Okay. The grayscale mode, and this is showing you 1 byte per pixel. And you can see the payloads show up in blue and everything else is in gray. Just to get a quick feel. So if you combine this with the filters that I'm putting in place, you can rapidly get a feel. You can blow through 5,000 packets in a matter of 5 minutes to get a feel what's the characteristics of the data set you're looking at. And then, like I mentioned, it operates in lockstep. So if we play it again, we slow it down, we can change the speed. And you'll see that they're both forming at the same time. And for example, if you wanted to turn on the strings command, right now it's looking for strings of length 6. It's just length 6. It's showing you the packet number and then the contents. And it's color-coded by protocol, so you can, if we speed it up, I found it useful to, hang on. You can play through the whole data set. And you can see things that, okay, there's a lot of these ping and pong commands, payloads, and then you can pause it when you see other things and take a quick look and you see the packet number. And right now we've already looked at 600 packets. Okay, you can see some FTP activity, for example. So the idea is just to speed up the forensic analysis process, as well as, depending on how much traffic you have on your network, lots of interesting stuff in here. So I think you can see where I'm going, and it operates in lockstep. All the views operate in lockstep. I'm also intrigued by the idea of applying some of these techniques into the reverse engineering field. Right here you see IDA Pro or IDA Pro. And I really want to, I'm trying to think beyond the canonical hex and ASCII display, where it has a tremendous amount of, I mean, that's like what everybody uses, but I think it could be augmented with some other techniques, and I'll show you some examples. For one reason, the information density, if you have a graphical object and you're comparing it, you can see approximately 40 to almost 1,200 times more information at the same time using a graphical display. So if nothing else is a navigation means within a large binary object, but I feel that if you type in disassembly information, that the two can be combined in a very powerful way. I have some examples. So this is a really basic prototype tool that I'm working on. I haven't distributed it yet because it's still needs some tweaks. But here's what it generated for various executable binaries. And you can see each one has a different fingerprint as well as a different structure. And I think things like the file format, the compiler used, that shows through. Now, this is 1 bit per pixel, so you can't see the entire file. So, if you're wondering, is Apache just that little bit of code? That's not correct. But you could also go to a green scale, which would give you 8 times more information in the screen. So I looked at different image files. Just looking at these are just the bits plotted, wrapped around. So and it's the same file in a variety of different formats. So you can see the image.jpg. You can see the header information right there. And then the file in BMP format. And then as a zip file, and you can see header information. And I believe in the zip file, can you see a grid? It's hard to tell. At certain distances, it's like one of those magic 3D puzzles. You can see things come out of the images. As well as when it's encrypted, you can look at a file and tell if it's encrypted. At least you could apply different entropy algorithms that would tell you, that you could use to color code this to show you what was really random and what just looked random. And I think, and there's been some work, and I have a pointer to it in the notes, that being able to look at different network flows as well as file formats or files. The file extension doesn't necessarily mean that it is what it says it is. So by looking at other means, such as this, or using the byte frequency, that you can tell more with a reasonable degree of certainty what it is. So this is MP3 files, and again you can see header information at the top, and a black area there, I believe, is space for additional header information. as well as interesting striations, solid areas in the images. And I believe these have the grid that you might be able to see, so that you can see the raw file structure. Now, clearly this is of a certain amount of value, but I think it really needs to be combined with intelligent ways to transform the data based on the file format. So you think this is an MP3, maybe you need to start doing some MP3 decoding to bring it to higher levels of abstraction that give you more information. Okay, let's go ahead and do a quick demo. So this is the tool. I'll go ahead and load a file. I'll have it load itself. So it's going to load the executable for this file. Something about computer science where I like to be a little useful. Okay, so the big green window is 1 bit per pixel, and it wraps around. So that's the whole file does not fit in there. The top grayscale square is 1 byte per pixel, so it's a 256 level grayscale. And you can see by the gray area at the bottom of that block that it fits the entire object on the screen. And then at the bottom is a low resolution view, but it's in full color, so 24 bits per pixel, and it maps red, green, blue, like I mentioned earlier. It also is designed to have this region. You slide the square around, and it'll change the views to show you what's inside that square. It isn't fully implemented yet. And I've also got it such that it's implementing a slice view. So it's looking at the most significant bit to the least significant bit and pulling those out individually. So if you're looking for funny activity at certain least significant bits, it might jump out at you. I'm planning on implementing sliders here that would allow you to change the dimensions, because that might give you additional insight as well if you could change the height and width. I believe I have this aligned on 32-bit boundaries. So let's look at another window. Now remember, each of these windows is a different window that you can combine with the others. You can put them all on your screen, and as you go through the data and you filter different things out, you have different views on the data. So this is similar to the rainfall view in that it plots 1 packet per line. But what's different about it is it plots whether bytes are there or not, byte presence in this particular view. So if you think the leftmost column is 0 and it goes to 255, it will turn the pixel on if there's if there's an asterisk, it'd be a 42. So that pixel will be on position 40, the 42nd position over would be the pixel would be turned on. And if you had the alphabetical strings, like here, you'll see the alphabet range of bytes occurs in this range. And if values change consistently between the packets, you'll see that in the form of diagonal lines. So based on the slope and direction, well, the slope of the line, either including the direction, you can tell the degree and rate of change of bytes between there. And the vertical lines, often I haven't pulled out the header information, so you'll see frequently the same value all the way through in every packet. But again, it's just another window. Each one of them, these windows by themselves, I don't believe cures cancer, but if you put them together, I think they're moving in the right direction. Particularly if I can get you to help me come up with some of the right directions to go and other windows to create. So let's look at some examples. The leftmost example is a dictionary file that I pulled down by HTTP, and the big red square in the middle of the leftmost picture is the printable ASCII range, so you can see a very high density of printable ASCII, as well as I have the diagonal lines, which are showing you, or kind of highlighting the values changing between packets very consistently. And then if you look at SSH, the middle example, Now, SSH is encrypted, so you would think it'd use every single byte, but oftentimes it's just single keystrokes or a very short amount of information. So in the region in the middle square, you'll see that not every byte is used. And then to the right, again, it's encrypted, but it's SSL. And these were larger files, so what it did was used every single byte. And you'll see that it skips lines because it's showing the responses as well. Now, that was just byte presence. I've also implemented byte frequency, where you have the ability to adjust a slider and say, I want this to be hot. Anything above 10% in this packet, I want to be colored as red, and anything below that threshold to be colored as blue. So, and you can slide it to whatever you want. So in the leftmost picture, you can see the printable ASCII range is hot, and everything else is blue. In SSH, it's about a mix in that it was small, it wasn't a lot of activity, and you expect it to be right there on the threshold if everything's random. And then in SSL, a slightly different view. And then the rightmost view is streaming audio. So based on how I had the threshold set at 0.56%, you can get a feel for just different protocols in action. And I've used this just on my desktop and watched how different protocols behave, and it's very interesting to see how they operate in real time. Okay, let me give you a quick demo of that. And if I've looked at these enough so they look clear to me. If I haven't explained it well enough and I'm just showing you random ink blots and it doesn't make any sense, please stop me and ask me, and I'll go ahead, I'll do my best to re-explain it. So if we go through, stop it. You can see it goes through the data set, and you can see the byte presence, whether there's given bytes there. And if you hover over it, it'll show you what field it is. For example, that's A, capital A, and so on. And you see down here we're getting to a lowercase k, etc. You can also change it to the byte frequency view. And now what comes up is this slider. And as it turns out, you usually have to be around 1 or 2% to actually see a difference. So we'll change it now. And anything occurring over 1.58% of the time is encoded in red. And anything below that threshold is in blue relative to each packet. I also have a slightly different view. And instead of, if you watch how it prints from the top and then it wraps around, you can also turn it on to slide. It's more processor intensive. I think that's almost a more natural way, but I need to do a little more coding to make it smoother. So anyway, I believe that technique's useful for byte frequency, for looking at files you haven't seen before. And if you combine each of these views as you get to suspicious data, each one gives you clues that are perhaps difficult to find in other ways, and put the clues together. So the initial, if you recall that initial view where the glyphs fired off to the side like battle zone, this one, and in the middle was 2 parallel coordinates. I've also implemented parallel coordinates that you can have any number of those and connect the dots. And research has shown that it goes from, say, 20 to 30 fields that you can view at the same time and still get something out of it. So again, you have the left axis, another axis, which I believe that left one was packet length. This is source IP, destination IP, and I think in this one it's also packet length, but that was just arbitrary. And then you connect the dots. This becomes really useful when I show you the demo. And here's what some things look like. If you see IP addresses, you see a natural X forming if they're talking back and forth to each other. And here's some streaming audio. And you can see at a glance, again, this could distill down 5,000 packets into one view. very quickly. So you can see the packet length distribution. And that just a couple of IP addresses we're talking back and forth. And a couple of TCP source and destination ports were in use, but no others. And that the IP identification fields were in use. And what's interesting, you can't tell from the static display, but you can tell as it goes, are they sequentially being appearing? Are they randomly appearing? You can also, as you play through it, at the end, you can say, this field was static. So you can run through this and see that, the time to live for this data set was 42 or 120, or 128, I guess. And also if you have suspicious data that you can go back and as you slide through the data, you might find some unique characteristic that applies to that suspicious data that you can then use to filter out everything else. And the idea then is you can just play through a whole data set of, last 24 hours on the HoneyNet or something and get a far better picture of what's happening. You can also change the columns to see relationships. Maybe there's a relationship between some crazy relationship between packet size, time to live, and IP address or something that will provide you an insight. And there are drop-down boxes, you can change the order. And here's another view. This is HoneyNet scan of the month, 21 again. And you can see, for example, a lot of different time to live addresses, lots of different port activity, and also that the entire data set, the don't fragment field was set. So you know at a glance that was the case. And again, this is a prototype tool, so I'm not saying it's like a production tool and everything's perfect, and you can send me bug reports and things like that, because it gets kind of messy when you get into the different versions of implementing different protocols. There's some subtleties involved, but I'm interested in your feedback. Okay, let me show you that. So this is the parallel coordinate plot. You can change the number of columns, so I'll set it for all 17 fields it does currently. And we'll play it and see what happens. And you can see on the right that area, you can see the IP identification field. You can see the ports in use, and we're already at 500 packets. You can change the playback speed to what's best for you. In this challenge in particular, I believe there was a flurry of UDP packets that you're particularly interested in. We should see that in a moment. So there we go. This is 3,300 packet data set. So in about 30 seconds, we'll be able to play the whole thing. Another way to work through the data set is to go one at a time. So you can go one at a time through and see what's going on in the packets. Let me bring up you can also bring up the packet detail view and go one at a time. Through it. Now don't have the packet detail view on when you're playing back a 5,000 packet data set though. It won't crash, but the way the tool's written, it only uses the resources if the window's open. So the idea then is you put up what you need, and it's not wasting cycles on what plotting, graphing things in the background. Because I'm slinging a lot of bits around here when you think about down to the individual bit on the network. Yes. Yes. Absolutely. The question was, is there a possibility to put a timestamp? Right now in the fields that I've pulled out, the PCAP files have timestamps. If you capture it live, you have access to the timestamp. In the version that you have now, I have not done that. And actually, I want to go do more fields and timestamp, and also the number in the field, in the packet is the natural one that needs to be done as well. And I'd be interested in talking to some PCAP people about, is there a difference in timestamps between different PCAP files? Is it different based on the hardware that it was captured on? like I could, I could run into some problems. I think I've dissected, so I skipped over it because of that. I didn't want to implode because of some different time scale, but I'm sure there's a way around it. But yes, and actually I like the game. So yeah, sequence number is obviously another one that makes a lot of sense. I've also implemented a scatter plot, and again the idea is any field to any field that you can compare and contrast. So it'll plot them in any combination that you want. And ideally you might be able to, that I'm heading towards using OpenGL and 3D to add a third dimension and then use color to show a fourth dimension, for example. But I won't demo the scatter plot because that's pretty straightforward XY plotting. So again, just going back to, now these snapshots came from the OpenGL version, and I haven't implemented the 3D view into the overall PVR, but I thought you'd be interested in some snapshots. And again, just recall it's the two vertical axes are connected and then the glyphs fire off. And if you see on the picture there, it plots in 3D the packet length. So you can tell at a glance the kind of the characteristics of your traffic. An important concept when you're dealing with these images is the idea of a baseline, because you need to know what normal is to be able to visually detect what not normal is. And Honeypot or HoneyNet is very good, for that. So we've been putting this on our HoneyNet, and this is what normal routine activity. And then we play back through the data set, and you may see things like that. All right. So if you see everybody on the internet all talking to one port of all packets the same size, it might be something you want to look at, and then you can jump to that in Ethereal and look at it in more detail. But you can get a feel for the big picture, what happened, very quickly. There's also the potential for, if you look, I had a class using oscilloscopes, you can measure things on the screen and get quick measurements, and I believe there's potential here for that as well. The OpenGL version does incorporate time. The sequence of time. Mine compresses, it takes out time right now and just shows sequence packet 1 after packet 2. So it compresses down time. The advantage is it's more dense display and shows you more information, but you lose the timing data. So I will be going to timing data in the future, though, and give you the option. Port sweeps, I know, they're pretty easily detected in many ways, but they do make for compelling visualizations, if nothing else. Port scans are very obvious. And then if you compare back to what normal was on the HoneyNet, and then if you float through the data set and you see that, perhaps you want to go and take a closer look. Or if you see something like that, you might want to go back and take a closer look. And those, again, the vertical is the packet size, packet length. A colleague of mine has been doing some research into botnets and lent me some of his data. So we tried it on the botnet data, and this is what, again, the IP addresses are on the left, the ports they're talking to on the right for inbound botnet data. And again, we could just take this strange data set, pump it in, and see what happens. And then outbound botnet. So now that single IP address is our target computer, our compromised computer, and who it's talking to on what ports. And you'll notice at the bottom, or at the top, just a cloud of general ports, and then a very denser cloud at the bottom of low ports. So this is the combined traffic if you're not filtering out inbound and outbound. And when we put it on, ran it live, and it's like the ticking of a clock. You can see how this thing is operating, that I can't imagine another way to get that much insight that quickly. So it's, particularly for strange protocols and such. So here's some links to some more information. Some of these that say email me are in a pre-publication pipeline, but if you want a personal copy for private use, you can send me an email. And these are in the book. I also have a link there to the byte frequency analysis. where I came up with the visualization, but there's some really neat work being done by Sal Staffo out of Columbia University on looking like what is that useful for. And also, I think I spelled the name right, Raphael Marty is giving a talk at DEF CON on visualization. It looks very interesting. So if you're interested in this, I encourage you to go to that. So there's a limit here on what the system can handle. I've chosen to focus on the packet capture files that you'd consider loading into Ethereum. Because of the graphic intensive nature, it scales to a point, but there's a tipping point. So I've been looking at honeynet traffic and small packet captures to get insight on the order of, I believe the tool will handle about 30,000 packets or something like that right now. Now this is some OpenGL performance on the SecViz tool, which is that OpenGL implementation. And we got 10 frames per second, which was usable for our needs. And it could plot about 35,000 packets on a commodity workstation. So that was reasonable performance and allowed us to go through data sets pretty quickly. So we've been running this on the honeynet trying to cap it for about a year now in various shapes and sizes, trying to shake out the bugs. And then some basic Win32 performance on the PVR that I showed you. So again, at best, it's at about 500 packets per second, and then it drops down on average to about 100 packets per second for some of the more detailed views. But again, I think that's reasonable when you're on the order of 30,000 packets. And what's that? Funny you should mention that. To graduate from school, that's what I need to do, really. And I've gotten it to this point. And I have a survey here, which I was going to ask nicely if I could talk any of you into filling out. It's really 2 pages in 5 minutes, and you might find it entertaining. That's kind of the first step. And then I actually, this fall, I need to actually sit people down in front of this and time them and see what they see, and have them use Ethereal and who's faster and for what cases and things. I'm not trying to beat Ethereal. I mean, Ethereal is great at what it does. I'm trying to complement Ethereal. So it's a very good question. So again, the tool is on your CD. I have it has a bug in it in that if it's the IP header length is over 5, it's not happy, so it'll crash. But it'll work. I gave you a data set. It'll do live packet capture. It'll work in general, just experiment with. And then I have a patch version that I'm going to post to a website I'll give you at the end that as soon as I get back from DEF CON. But right now it works with IP over Ethernet and requires a minimum of 256 megs of RAM. It's it's using a RAM buffer for most of it. Eventually I could interact with the database, but for now I wanted the speed. Processor is 300 megahertz minimum. Yes, it's a typo in the book. I have 300 gigahertz. 300 gigahertz is not required to use the tool. Okay, I knew somebody would call me on it, so I have to bring it up first. Screen real estate is key to this. I mean, it's awesome. I've got a 20-inch monitor. It works very well. If anyone wants to donate a 30-inch monitor or something to me, I'd be happy to take it as a private citizen and not as a representative of the government. Because I think you go to Leavenworth for things like that if I'm not careful. But anyway, you need a lot of screen real estate to use it well. It works reasonably well on a laptop, but it's really cool when you can have big screens. And I've used a virtual desktop as well. It's been an interesting complement. It runs off WinPCAP for now, and I envision porting it to Linux, or probably Linux, GCC, OpenGL for the increased performance. Once I've got the interface stuff right, I want to make sure it's built correctly and designed correctly, and then go for the optimize it at that point. Yes. Yes. I believe in sequence numbers. What do you think those diagonal lines are? What's that? Yeah, probably sequence numbers.
They're also going in reverse.
Yes. Yeah, I mean, a port, yeah. Well, you can plot them. You have multiple windows on the data. So you can plot one packet at a time. If you find, hey, that's an interesting point. It doesn't... So what field is that occurring at in the packet is probably what you'd be interested in. I think I haven't actually tried to work that specific problem, but I believe if you look at the rainfall view, it shows all the bits. You can see like a binary clock. You can see a binary clock, and you can see the changes per packet, specifically where it's occurring in the header structure. So you can actually see where it's occurring. And I think you could bring up a text window, you could bring up the rainfall window and step through it and be able to track it down. And also the byte presence view could have 100 bytes that were all behaving in the same way, and it could occur many places. But I think, again, in the rainfall view that showed all the bits, that you'd be able to see. But, like I said, I haven't cured cancer, so these are all good questions, and I'm going to scribble them down furiously. And what I want to do in the rainfall view that shows all the bits is, as you mouse over, it'll show you the offset into how deep you are into the packet, so you can see where you are, and then go to ethereal, say that occurred at packet 37, offset, blah, you can go see what's going on. Yes? Could you repeat the question? I'm sorry. Not at this point. Do I take into account if the packet has a V length or VLAN? No, I don't at this point. I was told I'd get a couple of feature requests out of this talk today, so I will write these down. Right now, the tool is set up and uses a RAM buffer, and it's storing entire packet contents because it's viewing entire packet contents. So I haven't addressed that problem yet. I think it could be piped into a database or something like that could handle it, or even flat files. But I think throwing things in and out of database would be the best way. As it stands now, about 30,000. And honestly, I think pre-filtering is almost the best way. That's a good question. I haven't gotten to that point yet. 30,000. I've got it. 30,000 as it stands now, but I think with the RAM buffer and reasonable commodity hardware, it could go up to 100,000. And if I actually had it in C and was using nice data structures and a nice rendering or OpenGL engine, I think you could probably get up to 1 million reasonably with some like supreme coding skills. You mean for the RAM buffer? It's coded in 15, 18 bytes, so it's not dynamic structure at this point. You had to ask me that publicly. I really know. Okay. Yes. I have not decided at this time. I don't know. There's this weird world I live in at Georgia Tech and what they think they own and what I own and things like that. Intellectual property law attorneys are welcome to have a chat at some point too. Yes.
In the section where you just highlight the no off.
Yes. In arbitrary string, sure. I definitely want to do that and that's just a natural thing. But you could see, the word password or whatever comes scrolling through. I have a couple more slides. When does this end? At quarter after or at 6:30? Okay, let me finish up the talk and then we'll get to some questions. So like I said, there is a tipping point, and we ran it on the campus backbone, and this is the fast version, the OpenGL version, for 5 seconds. So the campus backbone at the time was about 2.5 class Ps of traffic, And you can tell not a whole lot of utility here. So I'm focusing at the low-level, forensic, ethereal level. You wouldn't put ethereal, I think, on a 2.5 class Bs and let it rip. So we're kind of at that. There is a tipping point. But we did find out one thing about an appliance, a vendor appliance that we had that was doing the capture for us. Do you see anything about the capture that's suspicious? What's that? What Ed just says, it looks like it's losing data. Yes, the device was not capturing continuous data. So it was faster than the device, the very expensive, well, I don't want to admit that, but the device that we had out there that was capturing the data wasn't able to keep up with the line speed. So we thought that was interesting. And then even we tried it at a different granularity, a 10 millisecond capture, still a lot of data. You can draw general trends, but you're definitely not going to spot any subtle details. So where is this going to go in the future? I definitely want to, you're the target audience, and you're the people who use tools like this. I want to build something that's useful for you. I want to find out what your needs are and make sure I'm in line. I've talked to a lot of people, and I'll show you a slide in a second, and some of the people will help me. But I want to make sure I'm meeting what you need. I want to build some self-licking ice cream cone that nobody wants. You see that in academia on occasion, and they give themselves a design award for it or something. I want something people will actually use and be useful. I want to go to plugins if at all possible, because I think the true creativity is letting people out there design their own visualizations and be able to plug them in and share them and things like that. I think there's tremendous power for that. And I also want to, I've just looked at packets, but it's entirely doable to bring in, to recreate sessions and then go up to the recreate application layer. And actually, some of the views could be, maybe pop up an audio player if you want to try it as a voice over IP, or you could bring up a little browser and it would show the traffic as if it was a HTML or a web traffic. So I think there's a whole realm of, we can move up to semantic layers to have lots of interesting and useful upper components. As well as, there's no reason why we can't pull in different data streams. It'd be very cool to be able to correlate this with snort data, for example. And you see, these alerts and plotted, I color code, some of this traffic by snort alert level or something like that, or filter by snort. And that would require, some basic, formatting of pulling out the right fields, putting it in the right place, and bringing it back in an intelligent way. I also think there's value here in the education side of the house. If you're trying to train people on how networks work or how your network operates, I think there's just a monitoring training benefit here, perhaps in the classroom. But as well, I've been focusing on the forensic analysis side and the smaller ethereal size, packet capture size. I also believe there's a lot of potential to create smart books. Picture a book of images of what different things look like, and perhaps with analyst markup, perhaps with the filter strings used, perhaps with the filter strings used, that you can then have a smart book of images, maybe on the web, that everybody can use to see what things look like. Versus other techniques that are far more painful. So in the book, there's some slides. My website is in the book. I've got every paper I'm allowed to release is on there, and ones that are in the pipeline are generally posted. And like I said, I'm not afraid to share it with you as long as you keep it private. 500 of my personal friends here. The code itself is on roomit.org. It will be posted to roomit.org when I get back. I think they've released the con CD, right? You can go pick that up. So there's a version. One point, actually, this is a big point. It doesn't load PCAP files natively. I spent a week on it. It's a long story. But I wrote a conversion tool in C that will take a PCAP file and convert it to a file with a format that the tool's happy with. I understand that's a usability issue, and I want to fix that. I've got a sample data set in the correct format on the file, or on the CD. So a challenge. This is for fun, okay? So no one take my lunch money when you see the results, okay? So I'm loading a data set. Just kind of walk through an example. If we bring up the PVR, we can see it's 576 packets. And we can play it as text. Okay. We'll run it through the byte frequency view. And you can see there's some odd clouds of kind of unique signature. And you'll find as you use these, each protocol, each attack has, to varying degrees, have distinct signatures that are to varying degrees visible in given windows. So let's look at the parallel coordinate plot. So we're looking at all 17 fields. And we'll play it now. So again, at a glance, you can see that the packet length is constant. The protocol is UDP. The same IP addresses are used. And you can, again, look at each field and see what's constant, as well as you can see the randomized port, as well as the IP identification field going up in a rising manner. Any thoughts? Okay. And I created this because I knew the question would inevitably be asked. Okay, if you see here, you can see the header data. So these were sent over the wire. So yes, you can send pictures to HoneyNet operators if they're using the tool. Very, very cool stuff. I was trying to choose the most appropriate picture. So I'd like to encourage you, I'm giving a talk at DEF CON about attacking people through computers. And half of the talk is then using how can you attack this type of tool. I had a friend who was working a capture the flag exercise at Interzone, and he said, if we use that tool, we may have to change the rules because people will be able to see what's going on in a different way. So I wanted to develop the new approach and then take a step out and look at, well, how can people attack that new approach? And I have a paper on like this general attacking visualization systems you might find entertaining, and it's out there. And there's another one about attacking people through computers, and that's in the IEEE Security and Privacy pipeline, publication pipeline. I think it's due out in November or something like that. But again, the talk is at DEF CON, so you might find it entertaining. I have some good demos of attacking the system. It's also going to be, at least so I'm told, I've been working with the Concerto folks, and they're supposed to have it up on the screens at DEF CON. But before you decide to just crash my system because I just told you, some of the weaknesses of it, I'd encourage you to have fun with the system. Okay, and put pictures on the system, and please don't crash the system. I think it'll be good for entertaining the crowds and things like that. But of course, you can do whatever you'd like. But so, just to recap, the talk slides are on the CD, and it's an extended version. Notice I had almost no bullet slides. The code, the source code for the RUMIT tool, for the SecViz tool that's in OpenGL and in C++, that's under the GPL, and that's on your CD. It's, again, the author, Sven and I sat down and talked about releasing it, and he wanted to let everybody know that he just wrote it in a week, and we just decided to put it out there so rather than wait forever and to fix it and clean it up. So it is as it is. But there's a how-to in there as well. I've got a file conversion tool that converts PCAP to the RUMIT format. The malicious visualization paper that's related to this, I think you'll find entertaining, is on the CD. And I think you'll find this interesting. For those of you that have to make a business case every year to go to DEF CON, I was able to get an article in the Communications of the ACM on why computer scientists should go to hacker conferences, and it's a good, it's supportive of the community, and it's on your CD. So. Okay, and like I said, there's a data set. All right, and then my website is either gregconti.com or the one that's down there, and then roomit.org is the website to get the tool. There's a year-old version on there that I haven't updated because I've been holding off to release it here, and I'll have it up, a day or so after I get back from DEF CON. I really could use your feedback because you're the ones who, you're the experts on this stuff. And I can talk to students at Georgia Tech till I'm blue in the face, but I really want people who use it in the real world. So if you want to provide me feedback, fire it off. I'm interested to think about how I could scale the project because I can't do it all, but I also need to look at the whole intellectual property thing versus Georgia Tech, and I'm learning more about law than I ever wanted to. But anyway, your experiences using it, where it needs improvement, and that type of thing, and perhaps interesting data sets or snapshots. I'd love to build an online library of snapshots with little paragraphs saying this is what this is. It's a big space out there for viz tools. It's a big internet. So if you find interesting tools, I'm constantly searching, trying to find out, be omniscient and know everything that everybody's doing anywhere on viz tools. But if you find something interesting, feel free to fire a note. Again, I'd be eternally grateful. And as well as interesting viz views, because I think there's a lot of creativity out there. And between Black Hat and DEF CON, we have probably the most creative people on the planet in Las Vegas this week. So, as well as world experts in this space. So if you think of ways that this could be improved or whatever, corner me if you see me wandering around, or fire off an email. I have a survey. It's 5 minutes long, it's 2 pages. If you've ever used Ethereal or Snort, I'd be eternally grateful if you'd actually fill this out. It would help me graduate. Going back to Ed's question. A lot of people have helped me along the way to iterate and improve this to get it to the point where I think we're approaching, on the hype cycle, we're actually approaching usefulness. And hopefully I've captured them all here. And also, I've had a good experience at Georgia Tech. And if anybody's interested, they've got undergrad, masters, and PhDs in InfoSec. So if anybody's interested in that, you can fire off an email, and I'd point you to the right people or answer some questions. As well as the Information Security Center. They've got about 100 folks working on InfoSec. And I know R&D is expensive, particularly in industry, to have to constantly man an in-house R&D. So they asked me just to put a slide up and mention that if they're really looking for industry partners to collaborate on different security-related activity, as well as government partners. So the website is there. There's more information, or I'd be happy to link you up with the right people. All right. With that, let me pull out my notebook and you can fire. I want to capture your thoughts and your questions. Okay. Please. Thank you. Okay, so I'm kind of, all right. Yes, question. Is there a quick way to pull out FTP and telnet traffic? Not at this point. I mean, I haven't included the filters to the port level yet. So, I mean, you could at least do you can either do signature matching, which is something I want to add next, or resolution down to port, so you could filter by port. So at least an initial approach. But you could do the text-based matching, the strings and the text rainfall. That'll pull every printable ASCII out.